Hey Calculus, today this lesson is going to talk about continuity at a point. That means at a specific x value. That's a three-step definition, and we're also going to learn about a cusp. So let's start with the definition of continuity at a point. Again, that's a specific x value. A function f is continuous at x is equal to c. C is representing whatever x value you're at, if and only if the first step, f of c, exists. F of c, this just means a y value. So that means that there just has to be a point there. So whatever x value there has to be a point there. The second step, the limit as x approaches c, your x value has to exist. So there has to be a limit there. That means the left and right limits are the same. Has to be a great date. They have to meet in the same place. And the third step is those two things have to be equal to each other. The limit must be the same value as the y value, as the point. Okay, so we're going to use that definition, and we're just going to go through each of these examples. Okay, one thing to remember is that you have to go in order. Step 1, step 2, step 3. And if one step fails, you're done. So let's go here to example right here. Is the function continuous at x is equal to c? Yes or no? Well, let's go through the steps. Step number 1, is there a y value at c? C is right here. It's kind of hard to see. Sorry about that. All right, if we go all along this vertical line, there is no point there. There's no point. So it is not continuous. No. All right, there is no point. There is no y value at x is equal to c. So that is step 1, number 1. No y value. You're done. You don't have to check the other two steps. Okay, the next example. Is this function continuous at x is equal to c right here? All right, we go to the first step. Is there a y value? Yes, there is. There's a point right here. Now we go to the second step. Is there a limit? We trace the graph. Remember, think about that imaginary vertical line as we trace the graph. The left and the rights are the same. So step 1, there is a point. Step 2, there is a y value. Step 3, are they the same? No. The limit is right here. Okay? And the y value is way up here. So this is not continuous. All right? The y value is not equal to the limit. And that is step number 3. Okay, next example. We go through our steps. Number 1, is there a y value? Yes, there's a y value right here. Go to the second step. Is there a limit? Think of that imaginary vertical line through your x value c as you trace the graph. Hey, the left limit is down here. The right limit is up here. So the limit does not exist. That is a bad date. So this is not continuous. The limit, d, n, e. The left does not equal the right. Okay, what step fails? That is step number 2. The limit does not exist. Okay, fourth example. Step number 1, is there a y value? Well, here's my c. If I put in my vertical line there and I look for a y value, there is no y value there because there's a vertical asymptote. So there's no y value, you're done. You don't even check the other two steps. So the function is not continuous. There is no y value. Oops, can't spell y value. There's no point. All right, and that is step number 1. Fifth example. First step, is there a y value? Yes, there's a point right there. Is there a limit? As we look at that imaginary vertical line and we trace the graph, we're coming from the left, meets right here. We're coming from the right, that meets right here. So there is a limit. And in this case, they are the same. The limit and the y value are both right here. So that is continuous. Yes. All right, now, as long as there's a cusp here, let's talk about what a cusp is. A cusp is any sharp point in a graph. Let's go up to the definition. Okay, I'm at the top of the page. A cusp is a point on a graph at which the function is continuous. So this is important. A cusp, it is continuous at a cusp. All right, but the derivative is discontinuous. We'll know more about this when we learn about derivatives. But you need to know a cusp is a point on a graph at which the function is continuous. A cusp is a sharp point or an abrupt change in direction. So a sharp point looks like this or like this. That is the cusp. It's just a sharp point on a graph, but it is continuous. There is a y value there. The left and right limits are the same. There is a limit there, and those values are the same. So going back to this example, there is our cusp, and it is continuous. Think about the first definition of continuous you ever learned. Can I draw this graph without picking up my pencil? I can. So it is continuous there. It is continuous at a cusp. That's important. All right, so we have continuous here. We have all three steps. All right, let's go to the next example. Okay, let's go through our steps. Is there a y value? Yes, there is a point right there. Is there a limit? Well, if we trace the graph from both sides, the left is meeting here and the right is meeting here. That's a good date. So there is a y value, there's a point, there is a limit. Third step, are they the same? Yes, right here. The limit is equal to the y value. So this is continuous. You have all three steps. All right, let's go to page 2. Okay, we're just going to practice this definition one more time. Remember, you go in order, steps 1, 2, and 3. If a step fails, you do not have to move on to the next step. You are done. Okay, this is a picture of an example where step 1 fails. There is no point. There is no y value. There's a hole there. All right? The next example over. This is an example of where step 2 fails. There is step 1. We do have a point, but the limit doesn't exist. Because if you put in your imaginary vertical line, the left and the rights do not meet in the same place. It's a bad date. So this is an example of step 2 failing. The limit does not exist. And finally, this is an example of step 3 failing. All right, there is a y value. Step 1, there is a point. Step 2, there is a limit. The left and the rights meet in the same place. But the limit is here and the y value is up here. So the y value is not equal to the limit. Okay, so that was a short lesson, just the definition of continuous today, all three steps, and then we know what a cusp is. Thanks, calculus.